The popular image of the artificial intelligence boom is a digital revolution born in California, where software developers write the code for the future. But algorithms require immense physical computing power. The advanced GPUs designed by these tech giants are essentially useless without the hardware required to run them. This chart shows how concentrated the market for that hardware has become. A tightly integrated oligopoly of just 5 firms controls between 56 and 66% of the global semiconductor equipment pipeline. Tracking the most critical choke points in this supply chain leads to a handful of Japanese companies, historically known for monosodium glutamate, luxury toilets, and synthetic rubber. To understand the future of artificial intelligence, we have to look past the software and examine the atomic-level material science born from everyday consumer goods. These legacy companies survived decades of market disruption by redefining themselves. They stopped seeing themselves as vendors of specific products and began operating as material science platforms. When Japan's housing market stagnated, Toto realized they couldn't just rely on bathroom fixtures. Instead, they leaned into their underlying expertise, the precise casting and firing of ceramics. Modern 3D NAND memory requires etching hundreds of microscopic layers into silicon. Because this occurs inside a vacuum chamber, manufacturers cannot use traditional vacuum-based systems to hold the wafers in place. Toto solved this with the electrostatic chuck, a precision ceramic plate that uses a static charge to hold wafers perfectly flat without shedding contaminants that would ruin the circuitry. While Toto mastered the holding process, Ajinomoto solved a different structural hurdle: how to insulate the dense microcircuitry inside high-performance computing substrates. An Ajinomoto engineer named Koji Takeuchi spent months testing production byproducts to find a new use for them. He eventually developed a solid insulating film that outperformed traditional liquid resins. Even though corporate leadership ordered the project killed due to market skepticism, Takeuchi secretly hid his team across different divisions for a decade, continuing to refine the formula in private. That project became Ajinomoto Build-Up Film. It now holds a near-total monopoly in high-performance CPU insulation, generating hundreds of millions of dollars annually for a company still known for its coarse restore seasoning. The 1970s energy crises forced a similar pivot at JSR. When petroleum became too expensive for their synthetic rubber business, they used their polymer chemistry expertise to enter the market for semiconductor photoresists. These specialized films and ceramics only become chips when they are processed by hyper-specialized machinery. This visualization shows the selective dry etch process. Lam Research holds a 50% share in tools for this atomic-level material removal. Then, Tokyo Electron serves as the universal gatekeeper, providing the coating, cleaning, and deposition tools every advanced logic chip passes through. Even the transition from copper wiring to optical light creates a new choke point. Tower Semiconductor currently holds the only production-grade design kit for the silicon photonics used in AI data centers. Together, these equipment makers form an impenetrable toll booth. Building an AI chip requires paying them to manipulate the obscure materials provided by former consumer goods companies. While the software is global, the hardware is remarkably local. This narrow geographic corridor houses the entire foundation of the AI boom. Taiwan controls 90% of foundry capacity, South Korea dominates high-bandwidth memory, and Japan controls the upstream materials and equipment. Massive facilities like this one at TSMC are the physical manifestation of that concentration, highly localized centers that power the world's digital infrastructure. This geographic concentration creates significant risk. Multilateral trade controls and escalating tensions between the US and China directly impact the revenue of giants like Lam Research and Tokyo Electron. Western governments are currently spending tens of billions in subsidies to domesticate chip manufacturing, attempting to replicate this deeply entrenched East Asian ecosystem. The global AI industry is physically constrained by this narrow corridor of material science giants, a physical bottleneck that dictates exactly how fast the software revolution can move.